Hello everyone, we are from Group 6. Today let's explore a phenomenon of physics known as the photoelectric effect. This phenomenon consists of the understanding of light and laid the groundwork of the most fundamental concept in quantum mechanics. Discovered by Albert Einstein in 1905, Einstein proposed a groundbreaking explanation for this behavior by introducing the concept of photon, which is the particles of light. According to his theory, light is not just a continuous wave but also composed of discrete packets of energy called as photons. So, what is meant by photoelectric effects? The photoelectric effect refers to the emission of electron from a material when it is exposed to light. The electron that emitted from the material called as the photoelectron.
Photoelectric effect proves that light is not just a wave. Firstly, photon power. Photon power is when the light is made up of tiny packets of energy called photons. Next is energy hands-off. It is when light or photons hits a material. It can pass its energy to the electrons in that material. For the photons to be able to pass the energy to the electron in that material, the energy from the photons need to reach energy threshold. If the energy of the photons enough, which has reached the energy threshold, then the electron from the material will get excited and jumps out from the material surface. The term energy threshold refers to the minimum amount of energy required for a specific process or the phenomenon to occur. So, the photoelectric effect will only occur if the energy from the photons has reached the energy threshold. This is the illustration of the photoelectric effect for more understanding. So, if you shine a light on a metal surface in just the right way, instead of illuminating or warming it, a bit of light would hit like a tiny cannonball, knocking an electrode right out of the metal. Light with a low frequency like infrared or visible light would do nothing. But if you gradually increase the frequency of the light into the ultraviolet at some threshold color, suddenly electrons would start pinging off the metal like they were shot with tiny light pellets.
What is the significance of the photoelectric effect? The significance of the photoelectric effect is the emission or removal of electron, normally from the surface of a metal. This is done as light is shown on the metal. This is very useful proof that light can act as a particle due to the fact that there is threshold frequency above which the photoelectric effect only works. The threshold frequency is the lowest frequency at which enough energy, known as the work function, is provided to the electron so that it can be removed from the surface of the metal. This proves that light behaves as a particle, as it evidences that the interaction between the photon of light and the electron is one-to-one. Otherwise, if light could only behave as a wave, the photoelectric effect would occur regardless of the frequency of light and only have different time delays.
Now, I want to talk about the applications of photoelectric effect. Now, there are 4 applications of photoelectric effect. Number 1 is photo. Cell is the most important application. It is most commonly found in solar panels. It works on the basic principle of the light striking the cathode, which causes the emission of electrons, which in turn produce current. Number 2, photomultiplier tube make use of photoelectric effect to convert light intensity into electrical currents. Number 3, Photoelectric effect also finds application in photocopies, light meter, photodiodes, and phototransistors. And lastly, scintillators. A scintillator is a device that emits light when it attracts radiation from either source in the lab or a cosmic source.
The photoelectric effect, which refers to the emission of electrons from material when it is exposed to light, has several practical applications in life. Here are a few examples. The first one is solar cells. Solar cell or photovoltaic cell rely on the photoelectric effect to convert sunlight into electricity. When photons from sunlight strike through the surface of a solar cell, they can release electrons, generating an electric current. The second one is photocell in lighting system. Photocell or lighting-dependent resistor use the photoelectric effect to sense light level. They are commonly used in outdoor lighting systems, street light, and automatic switching devices. When exposed to light, the resistance of photocell changes, affecting the electrical current and triggering the control of lighting system. The third one is camera. Image sensor in digital camera use the photoelectric effect to capture and convert light into electronic signal. Photons striking the sensor generate electrical charges, which are the process to create digital image. Next is smoke detectors. Some smoke detectors use the photoelectric effect to detect smoke particles in the air. A light source and a photosensitive element are positioned in a way that, under normal conditions, the light doesn't reach the sensor. When smoke particles scatter the light, it triggers the photosensitive element setting off the alarm. Next is for security system. Photoelectric sensors are used in security systems to detect motion or the presence of an object. When the infrared light being emitted by a transmitter is interrupted due to an object or motion, the sensor activates an alarm or triggers a response. The last one is barcode scanners. Many barcode scanners use laser beam or photo detectors to read the information encoded in barcodes. The photoelectric effect is essential for converting the reflected light from the barcode into electrical signal that can be interpreted by the scanner. This example illustrates how the photoelectric effect plays a crucial role in various technologies that have become integral part of our daily life.
That is all from us, Group 6. We hope that you will now have the understanding of the photoelectric effect and how it affects our daily life.